Dhand. I'm the CEO and co-founder of QC Design. So far, we've been in stealth, but today it's my great pleasure to be talking for the first time in public about what we've been up to. We can confidently say that quantum computers will generate tremendous progress for the society and the industry. But truly breakthrough applications, truly valuable applications of quantum computers need tens of millions of gates. And going from the 10 or 100 gates that we can run on today's devices to tens of millions needs fault tolerance. A fault-tolerant architecture is a roadmap that describes how to put together imperfect components, such as those found in today's devices, into a reliable computer, one that solves the problem that you want solved. Fault tolerance is what allows you to build useful quantum computers in the real world. But it's hard to build fault tolerance architectures. And that's because this needs a team with expertise in fault tolerance and hardware, an exceedingly rare combination. And you need simulation tools that can potentially take years to set up and months to run. It's no wonder then that the list of companies that have demonstrated or claimed fault tolerance architectures is small. This leaves a massive gap in the ecosystem, with many quantum companies, big and small, looking for ways to get to fault tolerance. At QC Design, we fill this gap. We do this by developing and licensing architectures for fault-tolerant quantum computers. There are two classes of architectures that are relevant. Blueprints provide the fastest roadmap towards fault tolerance, and boosts allow hardware companies to do more fault tolerance performance with the same hardware. Licenses to these architectures are a game changer for our customers. And that's because this allows them to focus on the most high leverage hardware activities and supplement the efforts of their in-house fault tolerance teams. We've already developed architectures for photonics and NV centers in diamonds. These architectures allow you to do fault-tolerant quantum computing with chips that contain real imperfections, losses, crosstalk, fabrication errors. And that's why several quantum hardware players have expressed their interest in licensing IP with us. The interest from over half a dozen hardware players validates that we can build useful architectures with access only to publicly available prior art. And with every new architecture that we make, we have access to tools that can address even more hardware imperfections. So the next architecture can be developed faster, but is also more useful to our customers. So we really think that we have a promising market opportunity ahead of us today and into the future. Our architectures are made even more useful to hardware providers because of our complementary software offering. Plaquette is a powerful simulator. It allows you to understand the fault tolerance performance of realistic hardware via simulations. Not only does it allow you to do simulations, it also allows you to run fault tolerance experiments on real quantum computers from hardware providers of your choice. I'm pleased to announce that as of today, Plaquette is available for early access. Building fault tolerance architectures needs a team with very rare expertise. Previously, I worked at Xanadu, where I headed the architecture team, and we were able to develop the first fault tolerance blueprint, the first concrete blueprint for fault tolerance with photonics. Our co-founder, Martin Plenio, is a world leader in quantum technologies. He's developed many architectures that are tailored to hardware on platforms like NV centers, trapped ions, and superconducting qubits. And we've been able to bring together a team of experts in the theory and engineering of fault tolerance and experts in hardware who've spent years in the lab and know the ins and outs of the hardware imperfections. The impact of our IP is made even more powerful because of our revenue approach that aligns well with the success of our customers. Customers can license IP with us for a one-time upfront license fee. This already provides access to a development roadmap and saves hardware time and effort. In the long run, our main revenue will come from royalties on the compute time. A tiny fraction of the compute revenues from devices built using our designs. This way, it's clear that we succeed when our customers succeed. And that's true no matter which platform or platforms are the first to get to fault tolerance. Fault tolerance is the future of quantum computing. So if you're someone excited about designing fault tolerance quantum computers, check out Plaquette. And if you are in the business of building quantum computers, we'd love to support you get to your first fault tolerant qubits and advancing on the path to fault tolerance. Much like ARM's RISC architectures brought mobile computing to where it is today, we hope that our fault tolerance architectures will take quantum computing to the next level. Thank you very much for your attention.
Maybe I have a question. The royalty model is great, but as other startups I mentioned, fault tolerance is probably 2030. So how are you going to live between now and 2030?
Absolutely. It's really that we have, so the question is about how do we survive till 2030?
Yes, because we get zero revenues between, except the upfront license, but between now and 2030.
It's the upfront license fee. This license gives customers actual value today. It makes them faster against competitors. So this license fee means something for us and it means something for them.